Hello, my geometry students. Make sure for the notes today that you've got your calculator nearby, you got your pen or pencil, and you're ready to go. All right, so as this video goes through, it's going to stop you occasionally and ask you some questions. So just answer them to the best of your ability and then keep on going. So I'm going to zoom in a little here so you can see what's going on. So this is day 2 of our Polygons unit. So the first 2 questions are a little warm up from yesterday's notes. So when it says, what is the sum of the interior angle measures of a regular 15 gon? That means we have to use the formula from yesterday, which was the 180 times n minus 2. That's the sum of the interior angles. So if it's a 15 gon, we're plugging that in for n. So 180 times n minus 2. Oops. Just kidding. Put a 15 in there. All right, which means we have 180 times 13. So on your calculator, we can go 180 times 13. That's going to give me 2,340. That's the total number of degrees that would be in a 15-sided polygon. All right, when it says for part B, what's the measure of each interior angle? Well, each one, if it's a regular 15 gon, it means that they're all the same. So I can take that sum and divide it up 15 ways, and that's going to get my answer. So if we divide that by 15, we should get 156 degrees. All right, moving on to today's stuff. This next thing we're going to look at is not the interior, but the exterior angles. So we know exterior angles are on the outside of the diagram. So what I would like you to do is take a moment and for these triangles, add up the exterior angles. So 147 plus 81 plus 132. What do you get here? Oops, and I didn't even notice this one's not a triangle. This one is a 1, 2, 3, 4, 5. This is a pentagon. So add up those 5 exterior angles. So 111 plus 41 plus 55 plus 110 plus 43. So see what you get from those. All right, it should be that what we came out with is that this is adding up to 360. That's adding up to 360. So when it says, what is the sum of the exterior angles for any polygon? Cool thing is it's always going to be 360, no matter what the polygon is. Now, when it says, why does this happen? Well, do your best to kind of sketch this with me. Let's take that first triangle. If I draw that first little triangle, all the sides are just extended. So this is extended, extended, and you have those 3 exterior angles. So when you add up those exterior angles, 147, 81, and 132, they give you the 360. I'm going to take and kind of shrink this triangle down a little bit. So if I reduce the size, but I still extend, I would still have those same angles. Here's 147, here's 81, here's the 132. So now I'm going to really shrink this guy down. Teeny tiny little triangle, right? You don't have to label the angles every time, but it's the same 3 little angles. If I shrink this down so much that that triangle almost just looks like a single point, what you essentially have is you have 3 angles that when you put them together are creating a full circle. And if you know full circle, that is 360 degrees. So that's why this happens, is that it creates a circle and there are 360 degrees in a circle, right? Or you can say it forms, a circle. Maybe that would make a little more sense there. All right. So with that rule, no matter what the polygon is, the exterior angles always add to 360. So flip on over to the next page. There's a spot to write down all the formulas now that we know. So write them down carefully because you're going to use them throughout the notes. So the sum of the interior angles is 180 times n minus 2. And then to get one interior angle is 180 times n minus 2 divided by n. So that's only if it's a regular polygon, only if all the angles are the same. The sum of the exterior angles, 360, no matter what the shape is. And then think about the extension here. If it's 360 total, you would just divide it by the number of angles there are to get one exterior angle if it's, again, a regular polygon. All right, let's put this to use. So you got some practice questions down here. I'll do some with you and I'll let you practice some of them. So the first one, find the measure of the exterior angle for each. So you've got the terminology. You also have a diagram. So pentagon, we're talking 5 sides here. So if I want that one little angle, then I'm going to take 360 and divide by the n value of 5. So right to your calculator, 360 divided by 5. Every exterior angle for a regular pentagon would be 72 degrees. And so that's, imagine if, it was extended, each one. Those would all be 72 degrees right there. That's what we're talking about. All right, regular octagon, that prefix oct, that's that 8, think like octopus. So 360 divided by 8 for this guy. And we get 45 degrees. So this one right here would be 45. For the next one, try it on your own and answer the question. All right, I'm hoping that you came out with 60 degrees for that one. And then last one, I didn't have a diagram to match it, but a dodecagon. So think decagon is 10. The do is another 2 on there. So that's a 12-sided figure. So if there's 12 sides, there's 12 exterior angles. So 360 divided by 12. Oops. There we go. That would be 30 degrees. All right. Hopefully you're doing pretty well. Flip it on over to page 7. Now we're going to talk about some problems we have to set up an equation to solve. So for this next one, it says find the value of A. So when you look, you can see A in the expressions. In this polygon are STUV. So this is a pentagon, but because they're exterior angles, I don't have to calculate anything separately. The exterior angle sum is always equal to 360. So let's do it. Let's add up these 5 angles and set it equal to 360. So 7A plus 2A plus 3A plus 6A. We got one more. 2A again, and then equals 360. All right. These guys are all on the same side of the equation. We're just adding them all up. So add up those coefficients. So 7 plus 2 plus 3 plus 6 plus 2. We get 20A. And then equals 360. Now to get A alone, divide by 20. So 360 divided by 20, we get 18 right there. And this question just says find the value of A. That's it. Done. All right. For the next one, it says how many sides does the polygon have if each exterior angle is 18 degrees? So if I want to know how many sides, we are looking to find the n value. All right, so think about the rule. For one exterior angle, let me flip back to that page before. One exterior angle is 360 divided by n. So I'm going to set 360 divided by n equal to the angle it comes out as, 18 degrees. Think about how you solve this. If I want to get n by itself, I first have to get it out of the denominator. I can multiply both sides by n, and that'll get it to cancel on the left here. So I get 360 equals 18 times n, and then I can divide by 18. So to solve, I can grab my calculator and go 360 divided by 18. I get 20. It's actually the reverse of the question from above. So n would be 20, which means when it says how many sides are there, that there's 20 sides in that polygon, which we don't have a pretty name for. There is a name. I'm not going to lie, I just don't know it. But 20gon is what we would call it. All right, for number 4, same type of question. How many sides does the polygon have if each exterior angle is 40 degrees? So if we're saying how many sides, I want you to find n. So we're going to do the same setup because they're giving you a single exterior angle. So I can go 360 over n, and then this time equals 40. Right? I would do the exact same thing. If I multiply both sides by n, that'll get rid of it here. And then I would have to divide by 40. So if I get my calculator and go 360 divided by 40, I get 9. And so when it says how many sides, I can say 9 sides. If I'm feeling fancy, I know a name for that one. That's called a nonagon. That's my favorite one because it sounds a little goofy, but it's fun to say. So a nonagon. All right, so as a little shortcut, what you might have noticed was that when you knew the angle measure, what you ended up doing was just dividing 360 by it. Same thing, we knew the angle measure. Ultimately, we just ended up dividing 360 by it. So you can kind of like switch those two spots right there to get that final answer. So if that works for you, use it. If not, no biggie. All right, for number 5, this is very similar to number 2. So I want you to try it and solve for R. All right, now that you've tried it, let's check that answer. So it should be 4R plus 7R plus 5R plus 8R equals 360. And then 11 plus, what would that be, 13 there. So 24R equals 360. Divide by 24. We should have R equals 15. Hopefully your answer checked out. All right, you got one last one on this page. Find the measure of each exterior angle in a regular 16gon. So I'm telling you the n value. That is n. We're looking to find the exterior angle here. So a single exterior angle is 360 divided by n. In this case, we're going to plug the 16 on in here. So 360 divided by 16. That gives me 22.5. And that's degrees because that's the measure of the angle there. So it's perfectly fine to have a decimal. It's not okay to have a decimal for solving for the n value though. All right, you have one last page. Flip it on over. This last page here says the rule for any regular polygon. So regular polygon, the measure of an interior angle and the measure of the exterior angle are something. All right, well, look at the picture. This would be the interior angle. Next to it, that would be the exterior angle. And I just kind of abbreviated with int and ext there. Because they form a straight line together, think of a straight angle. What does a straight angle or a straight line, how many degrees are we talking about there? I'm hoping that you thought of 180 degrees. And so there was a nice term that meant that angles added up to 180, and that is supplementary. So the nice shortcut that sometimes you can use is if you know one, you're just going to subtract from 180 to get the other. So the last example shows you how you can do that. So the polygon here, we've got an octagon and a regular octagon. So all the sides are the same, which means all the angles are the same. So solving for an interior angle, this is good practice right here. So a single interior angle is 180 times n minus 2 divided by n. All right, the n in this case would be 8 for 8 sides. So if we do 180 times 8 minus 2, and then divide it by 8. Let's calculate what that'll give us. So 180 times 6, that gives us 1,080, and then divide that by 8. The answer comes out as 135 degrees. All right, so that's the measure of this angle right here using the interior angle formula. If I use the exterior angle, I'm not saying that X over here is an exterior angle. What I'm saying is extend it out and solve for the exterior angle. So based on what we know, the exterior angle is just 360 divided by n. Well, n is still 8 for this question, so let's plug it in. If we do 360 divided by 8, that would give me a 45-degree angle, but on the outside here. So if it's 45 degrees on the outside, and I want the x value on the inside, then x is equal to 180 minus 45. Well, let's calculate. 180 minus 45, that gets us 135 degrees, which matches my answer from over here. So I point this out because sometimes if we forget how to use one formula, we can use the other, or if I already knew this information, I can use it to solve for the value that I want here. So either way, you'll get to that answer, just two different ways to do it. All right, guys, thanks so much for watching.